There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
Empty your mind. Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash. Be water, my friend.
Be water, my friend. That was Bruce Lee explaining his water philosophy. For centuries, water was an essential part of philosophical thinking and teaching. The pre-Socratic Greek philosopher Thales looked at water as being the essential building block of everything, the principal substance. Without it, there would be nothing. No trees, no clouds, and no ground to stand upon. Following Thales was Empedocles. While still revering water, Empedocles placed it on an equal footing with fire, air, and earth. He couldn't see how it could be responsible for everything. Even Plato weighed in on water, attributing its solubility to its shape. Plato was of the opinion that the basic shape of water was a 20-sided icosahedron. Earth, he said, or the substance which makes up the earth, is made up of cube-shaped particles. I'm not sure why he didn't just say tiny spheres like ball bearings instead of something as complicated as a 20-sided shape. Maybe he used spheres for something else. But I suppose the icosahedrons make sense when you think about them. Take a box full of them and shake them around and they'll move about, rolling over one another. Do the same with a box full of cubes, and you might find them packed together, refusing to budge. Suffice to say, we've been fascinated by water for a very long time. Not only are we dependent upon it to live, we wouldn't be here without it. And I don't mean right now if all of it were to suddenly go away. I mean from the very beginning. Without water, there would be no life, anywhere. Or so our current understanding of how life may have gained a foothold on this planet tells us. Let's take a closer look at it. You know it as H2O. That's 2 parts hydrogen and 1 part oxygen at the atomic level. It's also capable of coexisting with itself in different forms on the same planet. And we don't have to go far to see this. We only have to look around. Depending on the temperature and the environment, it can be liquid, solid ice, or gas. Here in New England, where I live, there are days when I can step out onto my front porch and come into contact with all 3: snow, clouds, and light rain. I can swim in it, I can ski on it, and I can drink it. And if conditions allow, and I can get there, I could do the same thing on any other planet. And speaking of planets, the Earth looks like a blue marble from space because 71% of its surface is covered with water. Now, if you were to measure it, you'd find that just under 97% of that surface water makes up our oceans, essentially all of the salt water. That leaves almost 3% as fresh water. And get this, 0.003% of that fresh water in total is found in living things. Your body is made up of somewhere between 55 to 78% water. The thing is, we are lucky, extremely lucky that it is here at all, especially in its liquid form. And it doesn't need to be. In fact, as far as the universe is concerned, water in its liquid form is almost a rarity.
The fascinating thing, of course, is that the Earth was an extremely different place from the Earth that we know. The Earth of about 4 billion years ago was very, very different from the Earth of today. We cannot imagine present-day life living on the Earth of about 4.5, 4.6 billion years ago, when the solar system was just forming. The Earth was hot, the atmosphere was extremely different from the atmosphere of today. There was no liquid water on the Earth because it would all have been vaporized. The Earth was indeed extremely different.
That's Christopher Willis from the University of California, San Diego's Department of Biology during a lecture that he gave on the spark of life. As Professor Willis said, the Earth in its early stages was devoid of liquid water. It was a hot place and all of it was locked up in its gaseous form. And that's the thing. I mentioned that water in its liquid form is rare, but it's not rare when it comes to being present. H2O is no stranger to the universe. But the fact of the matter is, things have to be just right for it to exist in its liquid form. We just happen to live on a planet that is situated at exactly the right distance to the sun for all three forms to exist. Now think about it for a second. At sea level, water boils at 100 degrees Celsius and freezes at 0 degrees. That gives it very little wiggle room to flow about in liquid form, something which our planet actually provides. Our planet orbits the sun in a sweet spot, or Goldilocks zone as it's been called. Things have to be just right. A little closer and it would be too hot. Water would only exist as a gas. A little further away and all of it would be ice. Take Mercury, for example, the closest planet to the sun. Its surface can reach temperatures of 427 degrees Celsius, and that's hot enough to melt lead. And on Neptune, it's negative 218. Hello, ice. So you see, we're lucky. No flowing water equals a pretty boring planet, at least as far as life is concerned.
The most important requirement for life is liquid water. And that's the defining requirement for life in terms of our solar system. There's plenty of energy, there's plenty of carbon, there's plenty of other elements on all the planets in our solar system. What's rare, and which as far as we know only occurs now on Earth, is liquid water.
And that was senior scientist Chris McKay from NASA during an interview for the show Nova. And of course he's right, liquid water is rare. Push the Earth slightly away from the sun, or even closer to the sun, and we wouldn't find it here at all. Even a 5% push would do the trick. And if you're wondering why liquid water is so important, just ask Bruce Lee.
Be water, my friend.
The truth of the matter is, you are. Your cells are mostly water. The proteins which make up your body are dissolved in water, and its structure is formed in water. All of the chemical reactions which take place in your cells has water to thank. It's a solvent and a metabolite. Metabolites are chemicals involved in metabolic reactions. Water is both the cause of and the product of many of these reactions. And not only is it a solvent and a metabolite, the water in your body is also a delivery system. Just like underground water systems carry nutrients, water does the same thing in your body. It transports nutrients. It transports vitamins and other essential materials from one spot in your body to another. We need it for digestion just like plants need it for photosynthesis. It flushes out toxins, and it helps to regulate your body's temperature. And none of these things would happen were it not in its liquid form. And try to go without it for a few days. In a previous episode, we talked about the Cambrian explosion and the levels of oxygen that might have contributed to kicking the whole thing off. As life began its slow trek to world domination, it needed oxygen to do so. But without water, we would go from this to this. In plants, where photosynthesis takes place, water molecules are absorbed and oxygen is separated from hydrogen using the energy obtained from the sun. Some of that oxygen is then released where it is gobbled up by you and I, on land or by our marine animal friends. And it all started 3.5 billion years ago in a soupy mixture of chemicals, all contained in liquid water.
So you see here an evolution of ideas in our understanding of the natural world. And this, like I said, led to the concept of the prebiotic soup theory that simple compounds were made on the earth and accumulated in the primordial oceans. These underwent polymerization, producing increasingly complex molecules, some of which by chance were capable of catalyzing their own replication.
That was American chemist Geoffrey Beta, who had done extensive research on the origin of life and the prebiotic soup theory. That warm little pond was also Charles Darwin's favorite location for life's first appearance.
But if, and oh what a big if, we could conceive in some warm little pond with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc., present, that a protein compound was chemically formed, ready to undergo still more complex changes. At the present day, such matter would be instantly devoured or absorbed, which would not have been the case before living creatures were formed.
This is why water is one of the things, perhaps the most important thing, that science is looking for as it uses its telescopes to extend our gaze into space. The deepest reaches of space where spectroscopy is relied upon to detect water in its gaseous form, and the hope is its liquid form as well. On July 22, 2011, astronomers identified a large cloud of water vapor in orbit around a star 20 billion light years away from Earth. This massive cloud contains 140 trillion, yes, I did say trillion, 140 trillion times more water than we have here. Because water is so important to life, at least life as we know it, it's not a stretch to say that it's just as important for life elsewhere in the universe. And most recently, NASA announced the discovery of liquid water on the surface of Mars. But the universe gets more and more interesting, doesn't it? Evolution Talk is written and produced by myself, Rick Coast. And the music in this episode was composed and performed by Chad Crouch, also known as Poddington Bear, as well as Kevin MacLeod. Support for Evolution Talk comes from you, simply by listening. And if you enjoy the show, please share it with someone. And you can help the show and its continued existence by visiting evolutiontalk.com/support. Becoming a show patron, leaving a rating on iTunes, or just telling a friend about the show are all ways that you can help me promote and produce future episodes. And most of all, thank you for listening. And until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.